Alright guys, so here's what's been going on. I heard that you guys are having some difficulties with understanding exactly what's expected on section 8.3 in the worksheets. So we're going to go ahead and we're just going to go over the basics of each section on the video, and then if you guys have any questions, you're welcome to come next door to room 1002. I'm in there and I'm more than willing to help you out. So let's go ahead and move forward as soon as I remember how to do that on this thing. Awesome. There we go, I figured it out. So how to evaluate an expression with E as a base. This is really simple if you have a scientific calculator. If you don't, your cell phone will work for now. So what you do is, let's say we have E to the 5. I'm going to go ahead and shrink my point down just a little bit so that I write a little smoother. What you're going to do, very simple, is on your calculator you're going to find the button that says E to the X. Then you push the button that says 5, and then you push either equals or enter. It's pretty simple. Now the flip side of that, very important, some calculators, this will equal 140, I think it's 8 point something. But some calculators will give you 5. So what you need to do is you flip the first two buttons. 5, then you push E to the X, then you push enter. Alright, so for the first, I believe it is 6 problems, that first section up at the top of the page on 8.3, practice B, this is exactly what you guys are supposed to be doing. Alright, now let's go ahead and move on and take a look at the next one. The next section is identifying growth and decay. When we identify growth and decay, the first thing you need to stop and ask yourself is, what does growth look like? What does decay look like? Because if I give you a function like this, f of x equals e to the negative 3x, you don't know whether that's growth or decay unless you understand what growth looks like and what decay looks like. So let's go ahead and clear that off. Some classes got this, some didn't, but what I need you guys to do is we're going to go through a very simple flowchart. The first question you ask yourself, is the base greater than 1? If the answer to that is yes or no, you're still going to ask yourself the same question. If it's yes, you ask yourself, is the exponent, I can spell, I promise, positive? Now, notice how every question we're asking is a yes or no question. The reason for this is how the flowchart works is there are a series of questions that will identify growth and decay for you. What you do, actually, you know what, we'll get back to that in a second. Let's go ahead and finish the other side of this real quick. If you say no, you still ask yourself the same question. Is the the exponent positive? Now, here's where it gets kind of weird. You have to ask yourself, how does this work? Well, if the base is greater than 1 and the exponent is positive, that means as my x gets bigger, my value gets bigger. So we call that growth. And this makes sense. If I have 2 to the x, my base is bigger than 1. My x is positive, my exponent is positive. So if I were to plug like 100 in, it would be a big number. If I were to plug 1,000 in for x, it would be an even bigger number. So it's going to be exponential growth. But if my base is negative, if my exponent is negative, then whatever I plug in for x, it's actually going to make that get smaller because of the negative exponent property. So over here, if the answer is no, we're dealing with exponential decay. On the other side, because we're working with a base smaller than 1, we just flip it. Yes would be decay, and no would be growth. Now, I get that this can be a little strange, but take a look up here. Let me see if I can somehow erase part of what I did. I don't know how to do that, and I don't want to erase the whole flowchart. So go ahead, pause the video for just a couple seconds, make sure everybody has the flowchart copied down, and then when you're ready, push play. We'll move on. I have to clear the slide to go through this though. Alright, so let's go ahead and start with f of x equals e to the negative 2x. Very important, ladies and gentlemen, in order to do this and identify it as growth or decay, you have to know that the value of e is greater than 1. So we ask ourselves, is our base greater than 1? The answer is yes. So if I come back here, I'm not going to go back all the way. But if the answer is yes, then you follow through and you ask yourself, is the exponent positive? Well, here the exponent is negative. That's what the minus sign out in front of that 2 means. So if the exponent is negative, the base is greater than 1, we can identify this as exponential decay. That simple, ladies and gentlemen. Let's go ahead and move on. Again, if you have any questions with this, come next door. I am more than willing to help you out. Using exponent properties to simplify. There are 3 exponent properties we need to talk about here. The first one, e to the third to the second power. If I'm going to simplify and I take a base raised to an exponent and I raise it to another exponent, so I've got e to the third raised to the second power, we use what's called the the power to the power property. Easy way to remember it, it's really stupid. You do pow, pow, multiply now. It's a stupid little saying. I learned it way back, but it does still work, and it will get stuck in your head. Sorry. But we multiply the 2 exponents, so 3 times 2 is 6. Now we come over here, and we'll use the same numbers through all of it, just so that you can see. E cubed over e squared. What we're going to do when we have 3 e cubed over e squared, we're going to take those 2 exponents and we subtract them. So we get e to the 3 minus 2. All right, please notice the number on top goes first. The number on bottom goes second. So now that I've got this set up, I just subtract the 2 exponents and I get e to the first power. Since it's e to the first, we just rewrite that as e. One more example down here that you're going to have to know how to do. We got e squared times e to the 5th. We have the same base again, but this time we're multiplying. So what we do is we rewrite this as e squared plus e to the 2 plus 5. Now watch. This time order doesn't matter because we're adding, so e to the 2 plus 5 equals e to the 7. You're going to use these 3 properties to work through your next section. Alright guys, this video is starting to get kind of long. I don't remember the limit on how long of a video I can upload to YouTube, so we're going to try to get through this one quickly. Graphing. We're actually not really going to worry about finding intercepts because when we graph, we worry about 2 points. Whenever we graph, we worry about what happens when x equals 0 and x equals 1. So let's work on graphing f of x equals 3e to the 2x plus 4. Okay? So if we're going to graph this, you would plug 0 in for x, and you get 3 times e to the 0 plus 4. E to the 0 is 1 times 3 is 3 plus 4 is 7. Okay? So when x equals 0, y equals 7. Now we take a look and we say, well, what happens when x equals 1? Well, when x equals 1, you have 3e squared plus 4. And I'm just going to keep that in e form. I don't have a calculator with me right now as I'm working on this, but you guys would actually go ahead and multiply that out using your calculator. E to the second power times 3 plus 4. So when I'm graphing that, I have some idea, kind of, that 1, 2, 3, 4, 5, 6, 7, that's going to be up there. I can guesstimate, call E squared about 8. 8 times 3, 24, 28. That is a lot of dots, but we can just kind of put it up there. Now, very important, the final piece we need for asymptotes. We know this is exponential growth, so it's going to be following this general curve. But we need to know, where does this piece approach? Well, the asymptote here, this is how easy this is this number right there. Whatever that number is, that's your asymptote. So in this case, it's positive 4. So if I come up to positive 4, I can draw a line there. That's my asymptote. Now I know, going up, it's going to start off very close to the asymptote, and then it's going to shoot up. Those of you who do not know what an asymptote is, let's go ahead and make sure everybody's got this copied down. This is your example for the rest of the page. You guys, by the way, are only doing numbers 1 through 29. Now I'm going to erase this and define asymptote for you. An asymptote, very important, asymptote, if I can spell it, is a line which the graph will get infinitely closer to. The graph will get infinitely closer to. That's horrible. The graph, sorry guys, I write slowly when I'm trying to be legible, will get infinitely closer to, but it will never touch. Now, why would it never touch 4 in that last problem? Well, because I don't care how small you make e to the whatever power, it's never actually going to equal 0. It's always going to equal 1 over e to whatever. So, since it never equals 0, it can get really, really close to 0, but you're never actually going to get to the point where you're taking 0 plus 4. So, one more time, an asymptote is a line which the graph will get infinitely close to, but never touch. Is that clear? I don't know why I just asked a question on a video. It's not like I can hear your response. One more time, guys, I hope this helped out. If you have any questions, go ahead. You are welcome to come next door. You can also ask whoever is in the room with you if they can help you out. That would be great. If not, like I said, I'm right next door in room 1002. It's Mr. Siles' old room. Just come next door and I'm willing to help you out. All right, good luck on your assignment.